Greetings, oh wonderful geometry students. I would like you guys to get a piece of paper in front of you, your review. What I want you to do is I want you to be sitting at a table in a position of learning, not laying down on a couch with the computer running next to you or your phone, but to be in a position of learning. Have everything in front of you, all your tools, everything you need. And I know you might have seen the length of the video at the beginning and thought, oh brother, it's so long. And I don't even know how long it's going to be yet because I'm just doing it now, but I presume it will be because I actually went through it. I found some additional problems to do. So what I want you to do is have this piece of paper blank that you are going to on there write any theorem that comes up to help you, because there's nothing that's on here that's not on the test. Let's say that again. There's nothing on the test that's not on here. So I want you to keep a running list as we go through to help you study. And I also want you to pause the video and do the extra problems when I give them to you. So let's get going. These wonderful erasable pens are perfect for the first types of problems. So Hamilton will love this. And let's take a look. A pair of parallel planes. Okay, so you need at least 3 letters to label a plane. You can use 4. But I could say this right here. And those are parallel. So S, Q, U, W go in order. T, R, V, X. Or, so this is why these are great. You can do the whole front side here. So S, W, X, T. And go back right here. Q, U, V, R. Or we can do the top, bottom. Q, S, T, R. And bottom. U, W, X, V. Okay. Now, all lines that are parallel to RV. So I'm going to erase this so I can get focused on what this specific question is asking. All lines parallel to RV. So I'm going to go find RV and darken it so I have my focal point. And I need lines. So when you're reading these, make sure you see what they're asked for. Here it was planes, lines, 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 plane. Suggest you do that. Underline these things to help you. All right, so there's infinitely many lines parallel to it, but using this diagram, there's 3. TX, with a line above it, SW, the line above it, and QU, the line above it. And those can be in opposite order, each of those. All right, erasing. Now we need 4 lines that are skew to WX. So I'm going to highlight WX. So skew, again, remember means they're not parallel and they never touch. Okay, so they can't be in the same plane. So ST would not be correct because it's parallel. So I need something that's not parallel. And this is parallel QR and so is UV. So none of those are options. TX is also not an option because it intersects at X. So RV would be one of them. Those will never touch. QU is another one. Those will never touch and they're not parallel. Okay, also SQ up here, not parallel, yet it'll never touch. And TR, not parallel, never touch. All right, now I need all lines that are parallel to plane QUVR. QUVR, so the back here, so I'm just gonna get it so it jumps out at me. All right, now I need all lines parallel to that. Okay, so let's see here. I'm going to do WX, that for sure is parallel. I'm going to do ST, that is for sure parallel. And the plane goes both ways, so you can't just be imagining it going this direction. Remember, the plane keeps going up and down too. It's that whole back wall. Okay, so SW would also be parallel to it. And TX would also be parallel to it. Okay, so even though it's like you see it going this way because of the way I do the lines, remember a plane goes forever in both directions. All right, and then we need a plane parallel to QUWS. So one more erasure, and it's worth it to erase and keep trying to shade so your eyes see it. QUWS, QUW. Okay, so right here, I need a plane parallel to it. There is only one, and that's this guy over here. So I'm gonna do RVXT. Just make sure you don't jump across. It doesn't mean it has to be this order exactly, but you can't say RXVT. Okay, it's got to go either clockwise or counterclockwise, but in order. All right, excellent work. So now the next one's just telling you to identify types of angles, but it's, you know, we don't have parallel lines, so none of these are necessarily equal. We're just trying to locate parts of specific types of angles. Okay, so corresponding angles. Identify all pairs, so I'm reading carefully what it says. So let's start with 1. So angle 1, remember it sits in the same position on the other line. This is the transversal. These are your two lines. So you're looking for the same position on both of the lines. So it'd be 1 and 5. And that's how you write that. Angle 4 and 8. Angle 2 and 6. Angle 3 and 7. Same side interior. So keyword here, interior. So remember, you look at your two lines and they're on the inside. Okay, so they're between them, but the same side part means it's the same side of this line. So here's one pair, angle 2 and angle 5, and here's the other pair, angle 3 and angle 8. Alternate interior, so we're still in the interior, but alternate means we're crossing that line. So it makes like an X in the middle here. So 2 and 8, and 3 and 5. Alternate exterior, so now these are all interior. So now we're going to go to the exterior, which is outside of those lines. And again, it's alternate, so it's on the other side of this transversal. So angle 1 and 7. And angle 4 and 6. All right, so those are different types those. So you should be clear on all those. Now, sliding down. Identify all the numbered angles that are congruent to the given angle and justify. Two parts, identify, justify. So, identify all numbered angles that are congruent to the given angle. Okay, so here's my given angle. So which ones are the same as this? Well, I certainly can see that angle 2 would be the same. So I'm going to say angle 2, but then it says justify. How do we know? Vertical angle theorem. So right now, on that piece of paper that I said to keep a running list, you should have vertical angle theorem written down. Okay, and because I see these arrows, I know those are parallel. So it might look a little tricky to you, but this line you can think of it like that, so that you can see that these are what? Corresponding angles. So angle 4 would be the other one, and it's the corresponding angles postulate. So go ahead and write that one down. All right. Now we got this big tic-tac-toe board. So we got to find which angle. We're given this one, 75. So which one's the same as this? Well, I can start with angle 6. So I just am going to make a list. And why? Vertical angle theorem. Okay, so you already have that on your list. What else is the same as this one? Because if you notice, these are parallel and these are parallel. So I can go both directions. So I'm going to go down first. 11 is the same. Those are corresponding angles congruent postulate, which you have written down already. Okay, next, how about going this way? Angle 4, same reasoning. Corresponding angles postulate, just a different set of parallel lines. All right, well, how about right here? How about those two? What does that mean? Those are alternate interior angle congruence theorem. So add that to your list. All right, now we're going over here to look at the other one, other line. Right here. Angle 2. Alternate interior angle congruence theorem. So, as you can see, we've got this one, this one, this one, this one, and this one, and this one. But we know these are also congruent, and we can get there by using, different transitive properties. So I'm going to add angle 13 and angle 15 here as well by, I'm going to put transitive property. Okay, down to the bottom we go. This one is crucial that you make sure you read, and on the test it will be as well. So let's read this carefully. Developing proof use. Developing proof. Use the given information to determine which lines, if any, are parallel. So we're looking for that. That's the only information we're trying to figure out is for what they're giving you, can you determine any of these lines are parallel? If the answer is yes, which ones, and then sneeze. and then justify it with a theorem or a postulate. Okay, so that implies to me that there is one theorem or one postulate that would back it up. All right, so let's take a look at the first one. They're telling you here 11 is supplementary to 10. 11 and 10 are supplementary, these angles right here. Can that tell you that any lines are parallel? And the answer is yes, it can. It can tell you these are parallel with this as the transversal. And why? So first I'm going to write my lines, T parallel to U, and now I have to put Y. And it's the converse, the same side interior, our sup theorem, supplementary. So write that on your list. So that's the opposite one. The regular, the non-converse, tells you that if you have parallel lines, then the same side interiors are supplementary. But the converse, of course, always is proving parallel lines. So I'm going to guess most of these are all converse. All right, because we're trying to show parallel lines. So let's get rid of that. Maybe you should get an erasable pen for the test, because this is working really well. 6 and 9. Those are the same. Does that tell you any lines are parallel? Well, we can kind of see that we're making it going across this, can't we? We can see the Z with that middle line. So right there you can see which two are parallel. This one and this one. I think that was supposed to be an A. Doesn't look like one. And the reasoning is the converse of the alternate interior angle theorem. Write it down on your list. 13. Angle 13 and 14 are supplementary. Okay, let's erase. Take a look at what we have. No, I mean they are supplementary, right? They form a linear pair, but that does not help me figure out any lines are parallel. Because the only two lines these even touch are this one and this one. So, there are none for that. It's not that it's not true, it's true, but it just doesn't hit the point we're trying to look at, that the lines are parallel. All right, let's look at the next one. How about 13 and 15? Ah, that's a different story now, isn't it? What are those? Those look like they're sitting in the same position on two different lines. What two different lines? It's not this one up here. That's not even touching them. It's this and this. So I can say T is parallel to U. And then Y, converse again of what? Corresponding angles congruent theorem. All right, 14 says we have more supplementary angles. Where are they? 12, 3. Now, here's the truth. 12 and 3 is a little tricky because you could say 3 and 8 are the same. I'm just going to write it so you can see what I'm saying here. Angle 3 is congruent to angle 8, vertical angle theorem. And then you could say 8 is supplementary to 12 by the same side interior. Oh, no, you can't. Yeah, we'd have to assume. No, 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 no. That is incorrect. I am wrong. Because then when we write that, we are assuming they are parallel. This would be a none. I was going to say we could almost do it with a couple steps, although here it says with a theorem, so that would mean one. You're going to write none. All right, and 17, 2, and 13. 2, 13. What are those? Are those any types of angles? How about if I cover up this side over here? What if I cover up with my little notepad here this? You see them now? They are alternate exterior angles. We talked about those up on the top. So if those are the same, then we do have two parallel lines. Again, it wouldn't have anything to do with this line because that's not even part of the problem. It has to do with this line and this line. So A is parallel to B. Converse again. Alternate exterior angle congruence there. Write it down. So in here we had 1, 2, we had 4 different ones, the converses. All right, page turn. Now we get more to the mathematical type things, less justifications, just making sure you understand these different theorems. The first theorem here is the triangle sum theorem. That's what you're using in these problems, and that's the one that says if you have a triangle, all three angles add up to 180. Okay, so we're basically solving the problem. We're adding these up and subtracting them from 180. So whatever 180 minus 92 minus 63, and that is 25 degrees. You can double check when you're done, just to make sure you didn't make a silly error. Just add these three and make sure they're 180. Okay, same thing here. Got 20, 87, and we don't know. So I'm going to just 180 minus the 20 minus the 87. It's 73 degrees. And add them up. Same thing here. Well, we can add these. Well, you could have added these in your head too. You could add these in your head, 120. So 180 minus the 120 leaves us with 60 degrees for angle 1. All right. So again, let's just make sure we answered the question, measure of angle 1, and we found the measure of angle 1. Now, let's look at the next one. Find the value of each variable. So that means there's more than one in here. So you got to be clear and label them out. Up here, I knew that was 1. There was no other options. Here, there's other ones. There's 3 in this one. Okay. So the first one we can look at is, well, I'm just going to start over here. Do you see the triangle? Sorry, with all this clicking, I just don't know why I don't leave them open. So we're looking at this triangle. So we have 28 plus 39 plus what equals 180. So x is equal to whatever 180 minus 28 minus 39 is, which is 113 degrees. What theorem did we use here? That was, again, this one from up on top, the triangle sum theorem. I'm just going to write them here so you know where these are coming from. Okay, so we can get y. You can do these a couple ways too, by the way. So if you see it a little differently, there's usually many ways to attack these. But right now I'm seeing that this is 113. Let me erase the triangle part of it and get you to see this part of it right here. Got a linear pair. So linear pair theorem, add it to your sheet. Add triangle sum theorem to your sheet. So you make sure you know what those are. All right, so linear pair, we know these add up to 180. So 180 minus 113 is 67 degrees. Now I got that one. That was linear pair theorem. And again, we can do triangle sum theorem You could have done exterior, sum of exterior angles where these add up to this. Either way. I'm just going to do triangle sum. I know everyone's pretty familiar with that. So add these up, equal 180. So z is equal to whatever 180 minus 64 minus 67. The answer is 49. Okay, next. What are we looking for here? We got a 37 here. We need C, we need A, we need B. Okay. Well, again, I'll tell you and make sure you label them. I'm going to do A first because it's super easy. Because what are those? Vertical angles. So angle A is 37 degrees, and that's the vertical angle theorem. You didn't have to write all these. You just had to figure it out. I'm just telling you where I'm getting this from. Okay, so that's 37. We can figure out C by using the linear pair theorem. So 180, here's our linear pair right there. Or the other way too. 180 minus 37, which is 143. That's done. And now I need B. You can use triangle sum again if you want. Right here, triangle. (180) minus 109 minus 37 equals 34 degrees. Okay, so we got those done. I'm going to switch colors because it's all blending together. All right, what do we have in here? X, Y, and Z that we need. I see a vertical angle again right away. I always like to do those first because they're so easy. You don't have to do anything, any calculation, you just have to recognize them. So we have 63 here, so Y is equal to 63 degrees, vertical angle theorem. And then we can do a triangle right here. So we can do triangle sum theorem and do the Z equals 180 minus 85 minus 63 equals 67. No. What is that one? 32. Okay, so that's 32. Okay, and then we can get X couple ways. We could either do an exterior angle type thing, but I see that this is a linear pair right here. So that's 130, so that means this one's going to be 50. So you can do 50 plus 63 plus X. So I can do triangle sum again. There was another way as well you could have done it. X equals 180 minus 50 minus 63 equals 67. There's the 67. Otherwise, you could have done exterior angle is 130, and that should equal these two together. That would have been fine. All right, onward. This is the triangle exterior angle theorem. That's what we're using on these three. And that one is the one that states when you have a triangle and you extend one of the sides, this angle here is equal to its two remote exterior. So it's not equal to the one next to it that forms a linear pair. It's equal to these other two. So right away I can figure out, find the missing angle measure. Measure of angle 1 is equal to 99 plus 30. Which is 129. Same thing here. measure of angle 2 is equal to, oh, actually, whoopsie, sorry, I'm not paying attention here. So this is equal to these two added together. So I have to take 48.3 is equal to measure of angle 2 plus 26.8. So I'm actually going to end up subtracting the 26.8. And measure of angle 2 is 21.5. Again, it doesn't tell you have to do it a certain way, so you could have done linear pair theorem, subtracted this from 180, got this, added these up to equal the triangle, which is 180. All right, going over here, we need to get 3 and 4. So you can do it a couple ways. I see a triangle, so I can do this plus this, subtract it from 180 to get that. Or I also see I have this, which is the same as the remote exteriors added together. So I'm actually going to do that. So measure of angle 3 is going to be equal to 62. I'm actually going to write it down here. Measure of angle 3 is equal to 62 plus 44, which is 106. And then linear pair. So measure of angle 4 is equal to 180 minus 106, which is 74 degrees. All right, bottom, same actually type of problem, except that you guys need to know that a right angle is 90 degrees. So x is the remote exterior, so that's equal to these two added together, so that's 124. Measure of angle x equals 90 plus 34. And then measure of angle y is equal to linear pair, 180 minus 124, which is 56. What are the values of x and y? Okay, we did. Always double checking to make sure I'm answering these correctly. Oops, sorry. All right. Yay, we get to do constructions, and there's nothing different than what's on these. Oh wait, there was one more thing I was going to ask you to do. This was an additional problem, so let me put this back up. I actually wanted to ask you a couple random questions here. So grab your piece of paper, and I'm going to give you a problem, and then I want you to pause it and do the problem, and then come back and see if you did it right. So I want you to take this and copy it. So x plus 20, z, and 150. Can you figure out what x and z are? Pause it, do the problem, and then turn it back on. All right, so I have a linear pair here. So measure of angle z is equal to 180 minus 150, which is 30. So we know that's 30. So hopefully you got that one. And then the other one, you're like, well, what am I going to do? I can't do the triangle sum theorem here, can you? Well, actually you could. You could. Let's be honest. 30 plus x plus 20 equals 180. That would be fine. 30 plus x plus 20 equals 180. Or you could have noticed remote exterior and done that one. X plus 20 equals 150. So let's work them both out. So I'm going to combine like terms here, and I'm going to get 30 and 20, which is 50, plus x, which is 2x equals 180. I subtract 50. 2x equals 130. Divide by 2. x equals 65. Let's see if we get the same thing down here. Combine like terms, 2x plus 20 equals 150 minus 20. Yay! So you can view it either way. No, we're not. So we know x is 65 and y is that. And if I had asked you for all the angle measures, well, then that would have been 65 plus 20. So that'd be 85. All right, and the other question I wanted to ask you on your paper, so copy this one down. If I gave you this, 3 lines like this, let's see, what did I label them? A, B, and C. And I've got these arrows here, and I've got these arrows up here. What can you conclude? Stop the video, then and do it. What can you conclude? All right, so what can you conclude? Well, you know from the markings, A is parallel to B. And you know from the markings up here that B is parallel to C. That's given. So therefore, look at, we got our connector here. A is parallel to C by what property? That's right. I know you guys know it. Transitive property. Congruence. Write it down. New one to put on your list of theorems there. I think most of you are getting pretty familiar with it now. Okay, great work. Let's get to the constructions. Feel free to pause too. If this is getting too long and stuff, just pause the video, go do something and come back in a little bit. Okay? You know yourself best. All right, it says draw a figure like the one given, but we don't need to because they already have one. So I'm going to cross that off. Construct a line through Y that's parallel. Okay. So the first step we need to do is get our straight edge and draw a line through the point in the line here. Next thing is I need to make my arcs. So I'm going to open this up and I'm going to, I want to go less than the Y. You don't have to, it just keeps it less confusing. If I go bigger than the Y up here, then all of a sudden there's more overlapping and it gets confusing. So again, I'm going to hold the paper and turn. Hopefully I can do this with the screen thing here. But I'm doing a little arc here, that's all. I'm not doing a big circle. So we're going to do an arc till I hit. Okay, then I'll pick up my pencil. Got 18 pens coming with me on that. Okay, and I'm going to slide up to the Y. Okay, I'm not going to this, I'm going to the Y. And I'm going to do another arc. Turn paper. Okay, so now I have that. So the last step you need to do is we need to see how big is this arc, because this one intersects 2 lines, see? So I want to measure that so that I can then measure this. But of course we can't use and I'm not going to measure this way. I'm going to go up to this point because this has the intersection here. So I'm going to measure right here and look at that. Whoopsie. Yeah, I think I actually cut that a little short. Okay. Sorry. There. Okay. Now I'm going to slide up to this point right here, my new point, so I can measure that arc. I only need the little arc there. I don't need lots, but I can tell if you're doing things right by the markings. That is my next arc. Point. So now I just grab my straight edge. Whoops, I should take the paper off the screen. And I'm going to connect these two. And if you notice, perfectly parallel. Maybe it is a little bit, but don't worry too much if when after you draw it, it's just slightly off. Because sometimes even just the part of the point that you go through, it's fine. I can tell because I'm going to be looking for this line. I'm going to be looking for the two arcs. I'm going to be looking for these arcs. Okay. All right, next one. Construct a line that's perpendicular to this. Well, perpendicular means, remember, we're trying to imagine what it's going to look like. It's going to be a perfect line going straight down at 90 degrees. So the first thing you need to do is draw a circle around that so that you hit it in two spots. I'm going to extend my line because I don't want to work on that small of a surface there. So I'm just going to extend that, and you can do that too. And then I'm going to draw a circle around P. So put my point on P. And I want to have, and it doesn't have to be a full circle, but it has to be, so I'm hooking on the computer here. That's not working. And then I'm hitting the calculator. And I'm hitting the computer again. Okay, this is going real well. Okay. There we go. So I only had to do those two because these are the 2 points I want, right there and there. Great. Now I'm going to open this up so it's more than halfway. So right there it's half. I don't want half, I want more than half. Right? So just open it a little bit more. And we're going to do half circle. You wouldn't have to do the full half circle on this one because you do have 1 point already there. But I'm going to because it always works and it looks so pretty. Okay. So here's my 2 points, and it should go right through. But like I said, even if you just got one there, that'd be okay because you still just need 2 points to determine a line. Voila! Put your little right angle, and that's just perfection. Isn't it beautiful? I'm sure yours looks just as grand. Okay, so you know what? This is pretty much the same on here as up here. You still do the same thing. Yes, the point is off of it. But what I want you to do is extend that line because we don't need little problems like a line that's not extended long enough. As long as you're only using a straight edge and a compass, that's all you can use. Okay. So I'm going to do a circle, and again, I want to make sure I hit this in both points. Okay, I can't just hit the circle once, or the line once. 1 and 2. I can stop now because I've got my 2 points. These don't matter. Ignore the other markings on there. These are my 2 points I care about. Okay? So I'm going to open this up to more than half. And it is more than half, so I'm going to do my semicircle, and it's going to go right through P. I can see that, which is fine. And then I'm going to do my other semicircle. Oh, see? I'm not on the screen for one, which is a problem. So let me do that again. Here. So here and here. Straight edge. 2 points to determine a line. And again, if it's just slightly off like mine, it's like, kind of looks like it's, yeah, it's pretty good, I guess. But if it's just the slightest bit off, I don't want you worrying about that. Okay. We did this, and then we did the 2 arcs, 3 arcs. Now, next question. On this piece of paper, we need to cover that up. I just cover that up. Okay. And what I want you to do is I want you to write the directions step by step to construct this. So assume you have this question right up here, same exact question. Draw a figure, like the one given, and construct a line through a point P, which is not on A, B. Okay. So I want you to tell me now, how would you do that? How would you do it? I'll give you a hint. Mine has 5 steps. Okay? You have nothing given to you except those words. What do you tell me to do? Pause the video, write them down. Okay. All right, you should have 5. First thing is we have nothing written down. So the first thing you should say is we got to get this line on here. So draw line. Oops, I don't need to write line. I can just write AB like that. And then we don't have P either. So I'm going to draw point P not on AB. Okay, so those 2 steps were just basically getting the picture we started with. Now what was the next thing we did after that? We drew a circle around that P, didn't we? So that's the next one. The way you can write that is draw circle P, because that means that it's the circle with P as the center. So that it hits the line AB in 2 points. And I'm going to list them, C and D. I'm going to make names for them, whatever you want to pick. Okay, then what did we do next after we drew this circle? Then we basically drew another circle, right? It was an arc or circle. It's just easier to say circle. So draw circle C and circle D, whatever you label them, so they intersect at points, these 2, right? So we can just make names for them, M and N. By labeling them, it's easier than in this last step to just simply say, what did we do once we got these 2 points? We drew a line, right? So we can say, draw line M, N. All right, so hopefully you got that copied down. Okay, that was one I wanted you to do. There was another one I wanted you to do. Okay, if I give you 2 angles, 49 and 60, and it's a triangle, can you tell me the 3rd angle? Do that quick. Of course, that's 180 minus 109, which is 71. Okay? I have another one. I need space. Do I have any space? At the end I do. I'll do it at the end. Okay. You know what, that kind of goes with this. So I'm going to flip over to the back page here and put it on here. Here's another question. I'm going to copy this for you. If you're given copy it down. Again, take breaks as needed. Okay, now 1 second. I'm trying to remember what I was doing with this. Okay. Questions are, oh wow, what a nice smear job that is. Okay, we'll get rid of that. I don't like that. All right, what I want you to tell me what kind of angles are angle 10 and 14. I want you to tell me angle 3 and what are alternate interior angles. I want you to tell me what angle 4 and angle 6 are. And I want you to tell me what angle has to be congruent to angle 13 to prove x is parallel to y. And what relationship do angle 4 and angle 6 have to show m is parallel to n? Okay, kind of abbreviate a little bit, but that's what we're doing. So you can pause it, try those. All right, you should be back, and let's look at the answers here. 10 and 14. 10 and 14. What kind of angles are those? Good, corresponding angles. Okay, angle 3. I'm not using erasable, I should be using erasable. Angle 3 and what are alternate interior? Remember, it's got to be interior. So it's not going to be working with these two, because then that would be an exterior. It's got to be interior, so we're working with these two right here. So which one is the alternate interior? 6. Okay. Oh shoot, that's not going to work. Okay, and 4 and 6. This one and this one. What are those? Same lines. Same side interior angles. What angle has to be congruent to this one? What angle has to be congruent to that one to show that this is parallel to this? These two. This one. You got to go over. You're not going to go up here, because that's not going to help you show this, right? Not going to go here. That's not going to help. This one. Or, yeah, actually, you could do this one too. Either one of them. 5 would be corresponding, and 8 would be alternate interior. Either one of those would work. Okay, so you could have had 5 because it was corresponding, or you could have had 8 alternate interior. What relationship do 4 and 6 have to have? 4 and 6 have to prove m and n are parallel. What's the relationship between these two? Are they equal? No, they're same side interior, so they would need to be supplementary. You have to equal 180. Okay. Everybody got that? All right, back to this. Turn page. Now we get to the fun stuff. Wow, it's all fun. You know that. Slopes and everything. Okay? So let's be clear. You got to know how to do slopes, and you got to know how to do it without mixing up the letters. End of story. Slope is y2 minus y1 over x2 minus x1. Okay, you're going to do that constantly. You've got to be able to do it. Get the y's on the top and the x's on the bottom and not flip it. Okay? So when we're doing it, it says what's the slope of the line passing through these points? Okay, well, I'm going to find them. And I see that there are 2 points given here. Right here and right here. So I am going to be meticulous because I don't want to mix them up. So I'm going to rewrite them. And I'm going to write them above each other, because then that helps me to see my x's and my y's and not to mix them up. Especially if you're someone that makes a lot of little mistakes. I would recommend doing that, because now you can literally be like, okay, y's on the top. There's my y's. I'm not going to make a mistake on this. 4 minus 2 over. Okay, here's my x's. -4 minus a -1. Watch your signs. 4 minus 2 is 2. -4 plus 1 is a -3. Done. Okay, same thing. I got my 2 points. I don't care that they're right there. I'm going to write them like this so that I can say, okay, y's. Y's go on top. 3 minus a -6 over x's. 2 minus a -1. plus 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 9 over 3, which reduces to 3, and yes, you should reduce them. Okay, so do the little extra things here to help yourself. Now we have to write the equation of a line, and on this test you're going to have to write everything in this form. Slope, intercept. Okay, remember we have point slope as well, which I'm going to put right here, which is y minus y1 equals m times x minus x1. Okay. All right, so we're given these, and right off the bat, they give you a slope and a y-intercept. Boom, that's easy. I just need to substitute it in. Y equals the slope, which is 1/3, x plus the intercept, which is 6. Done. Next one, they give you slope, y-intercept. Great. As long as I don't lose my minus negative signs, I'm good. Y equals slope, -10, x plus -3. Or you could have said -3. They're both perfectly acceptable. Okay, what are we given here? Slope and point. Oh, slope and point. So I'm going to plug them in here first and then solve. So this is my x1 and this is my y1 and this is my slope. So we're literally putting them in here. So x, I'm going to write it over here. Y minus a -3. Don't lose your negative sign. Equals slope. -5 times x minus 2. So I'm going to change that to a plus. Y plus 3 equals -5 times x minus 2. Now I got to get it in this form. So I'm just basically solving this. How would I get it on the screen? Sorry about that. So I need to solve this for y. So first I'm going to distribute and get rid of the parentheses. Okay, I'm going to subtract 3. Oh, I can't subtract it from there. I got to go over here. And there you go. Y equals -5x plus 7. Next, slope, point, same exact thing. Okay, so I'm going to go up here, y, x1, y1. Slope, write them on there so you don't get mixed up. Y minus y1 equals slope, x minus x1, -8. So I automatically put my minuses in, and then I go substitute so I don't miss things. Y minus 2 equals 3/4 times x. I'm going to change that to a +8. Distribute 3/4 x plus 3/4 times 8, you guys. You can do that. 3/4 times 8. Cross cancel, and that's 6. Add 2. Y equals 3/4 x plus 8. There is your answer. Next. Given 2 points. Okay, neither of these say 2-point theorem. But I know from above that when I'm given 2 points, I can always get the slope. So that's exactly what you're going to do. Both of these need the slope. Doesn't matter. You have to get the slope first. So again, I'm going to write them this way so as not to make fatal errors here. So my y's. 6 minus a -2 over 0 minus 4. I have to go the same direction. Plus plus 6 plus 2 is 8 over -4. It's a -2. So now I'm going to have my slope, and I have 2 points, but I only need 1. Okay, so I'm just going to pick that one. X1, Y1. Plug it in. Y minus Y1. 6 equals slope times x minus x1, which is 0. Y minus 6 equals distribute. -2x, 0. And I'm going to add 6 to both sides. And you can see that you cannot put an x and a 6 together. So you have a -2x plus 6. Next. Again, 2 points. Great, I need 2 points, but I always need my slope every time. So put them in order, -1/8, 5, -4. Slope equals the y's on top. Don't lose your signs. 8 minus a -4 over -1 minus 5 plus 12 over -1, -5 is -6, -2. So I've got a slope of a -2. I'm going to put that here, and I've got 2 points. Great, pick one. I'm going to pick this one, x1, y1. Plug it in. I'm plugging it into my point slope up here. Y minus y1, 8 equals slope times x minus x1. I'm now going to simplify, make that a plus. I'm now going to distribute. I'm now going to add 8. And I am -2x plus 6. All right. Now we have to rewrite. Okay, let's see. Rewrite. I gotta highlight that because that sounds really like something I'll forget. Rewrite each equation in slope-intercept form. Then determine whether the lines are parallel. Okie dokie, artichoke. So we got 2 things to do. We got to rewrite, and then we have to determine. All right. Neither one of those are in y in slope-intercept form, because remember, slope-intercept form is this, which basically means you have to solve for y. So I'm going to take this one, and I'm going to solve for y right here. Well, the only thing I have to do is divide by 2. But remember, divide each term by 2. That's going to help you if you do it that way. So I get y equals, and there's a 1 here. So I'm going to write that as 1/2 x. You guys see what I did there? There's 1. Now I need to do the other one. So I'm going to take this one and go down here and solve it. Need the y alone. Move 5 first. So x minus 5. I can't put those together. It's 2y. And again, same as up there. I want the y alone. So I got to divide by 2 every term. So I'm going to rewrite it with the y on the other side here. So I'm just moving it over here, and I'll move this over here. And I'm going to put that 1 in there. 1/2 x minus 5 halves. Am I on the screen? Oh, good. Okay, so now what's the slope in here? 1/2. What's the slope up here? 1/2. Determine whether the lines are parallel. Well, class, are they? Yes. Slopes are the same. Next. I will take the top one right here and solve. I need to get the y alone. So I'm going to subtract the 130 first. Can't put those together. Need the y alone. Each term. Simplify. 50 divided by 10. What is that? 130 divided by 10. Done. Okay, I'm going to do this one down here. Solve for y. Remember, that's multiplied here. It's not subtracting. These are multiplied. That's why I'm dividing. Slope here is what? Boom. Slope here is what? Boom. Parallel? No. Are they perpendicular? No. All right. We're getting there. The last page, finally, you guys. This is a long review. Oh, I'm going to highlight again. Here's that weird stuff again. Rewrite and then determine. Okay. Perpendicular. So we're doing a little different now. So first thing I have to do, solve for y. Notice I lined it up because I can put those two together. Solve for y. I distribute first. Okay, you guys can do that. I'm just going to go right here. Negative 5, 6 times a negative 5 is 25 over 6. Be a plus, because a negative times negative will give you a plus there. Then we can add these. Yes, we can. We can add 3. Need a common denominator. So multiply this by 6. We get 18 over 6. So then 25 plus 18 is what? Sorry, I'm distracted here. What am I doing? 25 plus 18. 43. So it would be 43 over 6. Does that really matter? Not gonna matter, no, but that's okay. Slope is negative 5/6. Slope is negative 1. Are they perpendicular? No. And then to explain, I guess I missed on that last one. Believe it or not, I did miss something. Explain. These are easy. Slopes equal. Slopes not equal. Thank you. Somebody must have been screaming at me, saying you're forgetting something, Mrs. Sola. Because there is that. Now, how do you explain it here? Because negative 1 times negative 5/6 does not equal negative 1. Remember, it's going to equal negative 1. That's all. You can just write that. That's fine. Okay, next. Solve for y. These are a little tedious. Well, this is a little easier, isn't it? That one's done. Oh, this one's a little easier too. I think. Let's see. 2y equals 8x plus 17. Divide by 2, divide by 2, divide by 2. Y equals 4x plus 9. Slope is 4. Slope is negative 1/4. Are they parallel? Not parallel, perpendicular. Yes, because negative 1/4 times 4 does equal negative 1. Right? If you put that over 1, you're going to get negative 1. Good. Whew, down. Okay. Write an equation. Let's look at the next one. Let me erase this because I can't see what it says. Write an equation of the line perpendicular to the given line. Okay. So, if you're going to write an equation, we need back to these. It's great if it gives you the slope and the intercept, but you for sure need the point and the slope, and then you can solve for that. Well, let's see what we have here. We have a point. Okay, so we have the x1 and the y1. comma. But this is a line, we want a line perpendicular to this one. So I'm not going to use anything in here except the fact that it did give me the slope. So I can figure out the line, the slope of a line perpendicular by doing the two things. Reciprocal and what else? Switch sign. I highly recommend that you highlight these words so that you don't mix those up. So I have this point, and now I'm going to have the slope of what? Change the sign so it's positive and flip it 1/3. Okay. Now I just need to plug it in. Y minus y1 equals slope times x minus x1. Y minus y1 is 2 equals slope x minus x1, which is 6. I'm going to distribute. 6 times 1/3. 6 times 1/3. 2. Add 2. Add 2. Y equals 1/3 x. And that's okay that you don't have another number on that side. Over here, same thing. Got a point. You have the slope of this line, but I need the slope of a line perpendicular to it. So I'm going to flip it and take the opposite side. Okay, then I'm done with that. I don't need that anymore. So y minus x1, y1. A -3, be very careful there, equals slope, -2, times x minus 0. So y plus 3 equals -2, and x minus 0 is x, so -2x minus 3 minus 3, y equals -2x minus 3. Okay, the y-intercept in these are irrelevant. That is not helpful. The only thing you need from these equations that they give you when you're looking for a different line is a slope. Now in this case, it's parallel, so it's even easier. They give you the point. Now you do want the same slope, because parallel lines have same slope. So the slope here is -5, and you don't have to do anything with it. Now you've got a point and a slope, and you pop it in. x1, y1. Ooh, I almost missed it, guys. As I'm writing, I'm noticing, oops, there's a negative there. Equals slope, x minus 5. Y plus 2. Distribute. Subtract 2. Okay. And lastly, slope 2/3. Done with that now. I don't need that. I need that. I need a point. I don't need this anymore. Once you get the slope, it's gone. Okay, y minus 6 equals slope x1, y1. X minus x. Y minus 6 equals 2/3 x. 0, add 6. Y equals 2/3 x plus 6. Done. All right, last thing. Then we are finally done. This was a long one. Yikes. Okay, 2-column proof. Number 1, don't panic. Number 2, put your given down. Number 3, mark it. Okay, I'm going to use a brighter color and purple on here so I can see my markings better. Okay, now let's see where we're going. Trying to show 4 is supplementary to 15. So somehow we got to get around the clock here and get connected to 15. Okay? So what I'm saying is, what can you do? Can you tell me something that 4 is the same as? There's a couple ways you can do. You can do this multiple ways. Okay? I'm just going to do it. Let's see. What way should I do it? I'm going to do 4. The first thing I see is 4 to 8. Okay, so I'm going to do that. You might have seen something else. 4 is congruent, angle 4 is congruent to angle 8. And why? What kind of angles are those? corresponding. And we have parallel lines, so we have this corresponding angles congruence postulate. And then I'm going to say that 8 is congruent to 14. Alternate interior angles congruent. Yeah. So I'm here now. Then I'm going to say angle 4 is congruent to angle 14. Right here. Transitive property. Congruence. So now I've got these equal. I've got 4 congruent to 14. Well, I'm going to say 14 is supplementary to 15. Angle 14 is supplementary to angle 15. Because why? Linear pair theorem. Now I'm going to say our grand poobah here. Angle 4 is supplementary to angle 15. Do you know why? Because I just said these are the same. So I'm going to substitute the 4 in there instead. All right, now, if you've made it this far, kudos to you. I hope you do really good tomorrow. Know that there is no full proof on the test tomorrow. There will just be the justifications. So that might bring a slight peace to you. All right, have a great day. Bye.